Hi, I'm Asia Fernandez, and my chapter was aqueous ionic equilibrium, and my question was Can Academy 17.3. So the problem states, what mass of sodium benzoate should you add to 150.0 milliliters of a 0.15 molar benzoic acid solution to obtain a buffer with a pH of 4.25? Assume that the volume of the solution does not change when you add the salt. The values given to us were the volume of benzoic acid solution, which was 150.0 milliliters, concentration of benzoic acid solution, which was 0.15 molar, and the desired pH of the buffer, which was 4.25. The problem presents a scenario where sodium benzoate needs to be added to a benzoic acid solution in order to create a buffer with a pH of 4.25. The question asks for the mass of sodium benzoate needed to achieve this. To solve this problem, we will need to use the Henderson-Hasselbalch equation, which relates the pH of a buffer to the concentrations of the acid and its conjugate base. The equation is as follows. pH equals pK plus the log of the concentration of the conjugate base over the concentration of the acid, where pH is the desired pH of the buffer, pK is the dissociation constant of the acid, A is the concentration of the conjugate base, and HA is the concentration of the acid. First, we need to find the pKa of benzoic acid. The pKa can be found in a reference table or calculated using the following equation, where Ka is the acid dissociation constant. So I did the negative log of 6.5 times 10 to minus 5 equals to 4.187, which rounds to 4.20, which is the pKa. Since we know the concentration of the acid, which is 0.15 molar, we can solve for the concentration of the conjugate base. We do this by substituting the concentration of the acid into the Henderson-Hasselbalch equation, as well as the pKa value that we just found. So pH equals pKa plus log of concentration of the conjugate base over the concentration of the acid. 4.25 equals 4.20 plus log of the concentration of the conjugate base over the concentration of the acid. So then we move the pK value to the other side, and we do this by subtracting it from the pH. So we get 4.25 minus 4.20 equals the log of the concentration of the conjugate base over the log of the concentration of the acid. This gives us 0.05 equals log of the concentration of the conjugate base over the concentration of the acid. And then we have to get rid of the log, so we raise it to the power of 10. So 0.05 raised to the power of 10, and the log of the concentration of the conjugate base over the concentration of the acid to the power of 10 gives us 1.122 equals the concentration of the conjugate base over the concentration of the acid. So we can then isolate the concentration of the conjugate base to give us concentration of the conjugate base equals 1.122 times 0.15 equals 0.168 molar, which is the concentration of the conjugate base. So then we have to solve for the mass of sodium benzoate needed to make the buffer, which is what the question was asking us. And to do this, we first need to get the molecular mass of sodium benzoate, which is 144.11 grams per mole, and we can do this by using the periodic table and adding the different elements in the compound together. And we had just solved for the concentration of the conjugate base, which is 0.168. And we are given the volume of the solution, which is 150.0 milliliters, but we need to divide that by 1,000 in order to get the concentration, the volume in liters, which is 0.150 liters. And so then we use the formula, we substitute the formula for moles into the formula for concentration, and we get the concentration of the conjugate base equals mass of C6H5COO negative Na plus divided by molar mass over volume of solution in liters. And when we add the values into this, we get 0.168 molar equals mass of the conjugate base divided by 144.11 grams per mole over 0.150 liters. and then rearrange to isolate the mass of the conjugate base. And we get mass of the conjugate base equals 0.168 molar times 0.150 liters times 144.11 grams per mole, which gives us a final mass of 3.63 grams of the conjugate base needed to be added to obtain a pH of 4.25. Thank you.